All right, class. So today we're doing online class. You have a set of problems in the discussion board. Each person has two. You're to solve those two problems and then take a picture of them and post them to the discussion board or type them out, whatever you got to do. And you have till midnight Sunday night to do your two problems. What I'm going to do is show you how to use, how to solve determinants and then how to use them to solve problems. All right. So we've done matrices. So if we have x plus 2y equals 3 and x minus 2y equals minus 1. Let's suppose we have that. Okay, fairly simple. If we were using elimination, we would simply add these things together. We would get 2x is equal to, because 2y minus 2y would cancel out. We'd have 2x equals 2. X then would equal 1. We then take that 1 and plug it back in the original problem. We would get 1 plus 2y equals 3. Subtract 1 from both sides to give us 2y equals 2. Y is equal to 1. In that case, the solution set is 1, 1. And that's a way of solving that. Now, if I were to ask you, and I'm going to go quickly because you can pause the video anytime you want. So, now if I were to ask you, though, to write this in matrix form, what I'm hoping you would be able to do is to write the following. That you'd be able to write this system of equations in matrix form like this. It would look something like that. And what we would do is drive this to 1, it's already 1, that to 0, that to 1, and that to 0, and that would give us a system, the solution to the system. Now, what I want to do is look at blocks of these. Let's ignore for a second the answers, okay? So let's just look at this piece of it. Suppose we just have this, and we want to write that as a matrix, and we wrote it like this: 1, 2, 1, minus 2. All right? And if I said, find the determinant for this, there's a system for doing this, okay? And the way it works is as follows. You take this top number and you multiply it by this number, from there to there. And you get 1 times minus 2. So we'd say equals this determinant. And then we'd minus, and then we'd take that one times this one. 2 times 1. And that would give us minus 2. Minus 2 times 1 is 2, which would be a total of minus 4. We'd get minus 4 for that. Okay? That's called the determinant. Let's show you another one. What if I did this determinant? I had 1, 1, 3, minus 1, and I said, let's do the same process with that. So we take 1 times minus 1. We take 3 times 1, so minus 3 times 1. This will give us minus 1 minus 3, which is minus 4 also. And then what if we did one more determinant? What if I did this one? 2 minus 2. Oops. Sorry, 3 minus 1, 2 minus 2. And I'm going out on a limb here, but I'm expecting to get the number minus 4 again. So this will equal 3 times minus 2 minus 2 times minus 1. So that gives us minus 6. 2 times minus 1 is minus 2 minus that. So minus 2 minus, that's plus 2, which equals, sure enough, minus 4. Okay, so those are 3 determinants. All right, those are determinants. So we can use those to solve problems, and I'll show you that in just a minute. I want to do a few more of these determinants, and then I'll show you how to use them to solve the equations, a system of equations, okay? So let's take a look at a couple of determinants here. How about this one? We'll do this one. 3, 2, let's say 4, 1. We're going to find the determinant. Now again, on the determinant, we're going to take this top corner and multiply it by the opposite corner, 3 times 1. And then we're going to go minus this top corner, 2 times this, 2 times 4. 3 times 1 is 3, minus 2 times 4 is 8, equals minus 5. And that's this determinant. This is, you write this, it looks like a matrix, like a matrice. It's not, it's a determinant. And we're going to do this and this. Now, they can be 2 by 2 like this. That's all we're going to do. I'm not going to do the 3 by 3s. Determinants in 3 by 3, I could show you. The book has examples. They're super complex. I think learning this is sufficient for now. I might show you on Monday how to do a 3 by 3 determinant, but I'll show it to you quickly just so you have a feel for it, but I'm not going to put it on the test, okay? All right, so now let's do another determinant. Suppose we have this, minus 1, 4, 2, 5. Suppose that's we're going to find the determinant of this, all right? And again, we're going to take minus 1 times 5. And then we're going to subtract 4 times 2. So minus 1 times 5, minus 1 times 5, minus 4 times 2. This is minus 5, minus 8 is minus 13. All right, one more. 4, 7, 2, 8. So the determinant is 4 times 8 minus 2 times 7. 4 times 8 is 32 minus 14. And this is, what is that, 22 minus what? So 18. So the answer to this one is 18. So there are 3 examples of determinants. And so the one thing I would caution you about is to be careful with the signs. You got to be real careful with the signs. Since you're subtracting here, you have to be careful. If one of these is negative, you have minus a minus, which makes it positive. So that can be complicated. All right, again, I'm going to move quickly because you can pause and you can go back and watch. I'm going to do one more determinant. I'm going to make it a little more difficult in terms of the signs. So let's suppose on this determinant, we have the following. We have 4, and then we have minus 2, and we have minus 3, and 6. Suppose it looks like that. So we're going to do 4 times 6 minus, and then we're going to have minus 2 times minus 3. So we did 4 times 6 and minus 2 times minus 3. So that's 24. Now you see minus, a minus, and a minus. A minus times a minus is a plus, times another minus is a minus. So we're going to get minus 6, and that is going to give us the number 18. 18. So that's how you do determinants. Okay, that's how you do the determinants. Now, how do you use them to solve a system of equations? Again, you can pause and go back and look. What we're going to go back to is this original system. X plus 2y equals 3. X minus 2y equals minus 1. All right? Now I'm going to write the basic determinant. We call that D. It's going to be 1, 2, 1, minus 2, and it equals minus 4. Now, there's another 2 determinants here, dx, dy. And the way dx functions is that when you write the determinant, you take the answer set, 3 minus 1, and you put it over here. So it goes 3 minus 1, and then you leave those the same, 2 minus 2. And then for the y, you write down the x's, 1, 1, and then you write the answers in for y, 3 minus 1. So this is going to be 3 minus 2 minus 2 times minus 1. This is going to be 1 times minus 1 minus 3 times 1. This is minus 6 plus 2, because minus 2 times minus 1, 2, that equals minus 4. And this is minus 1 minus 3, which is equal to minus 4. So now we have these three determinants. We have the d, we have the dx, we have the dy, and the way we find x and y is as follows. X equals dx divided by d, and y is equal to dy divided by d. So dx divided by d is minus 4 over minus 4. Minus 4 divided by minus 4. dy is also minus 4 divided by minus 4. Now minus 4 divided by minus 4 is also known as 1. Minus 4 divided by minus 4 is 1. That means our x and y are 1 and 1. And so that's how you can use determinants to solve a system of equations. All right, so let me show you another one of these. I'll give you another example of these. Let me give you a different equation set, and then we'll do the same exercise of finding d, dx, and dy. All right, so let's take a look at this. Let's take another equation. Let's suppose we have x minus 3y is equal to seven, and 2x plus y is equal to 0. Let's suppose those are our numbers, okay? Now, again, we have three determinants here. We have d. D is just using these here, these multipliers in front of the variables here. 1, 2, minus 3, 1. All right, so this determinant, we're going to take 1 times 1 and then minus 3 times 2. And this will equal 1, and notice there's a plus there. 1 plus 6 is equal to 7. See, minus 3 times 2 is minus 6. Minus a minus 6 is plus 6, gives us 7. Now, what is dx? So for dx, we're going to write the solution in for x. X is 7 and 0. The solution goes in here. And then we just write minus 3 and 1. So you'll notice we get 7 times 1 minus 3 times 0. 7 times 1 is 7. Minus 3 times 0 is 0. So this whole thing goes to 7. Now, dy is equal to, we're going to write 1 and 2, and we're also going to write minus 3 and 1. So we're going to solve this. We'll say 1 times 1 minus 3 times 2. And this works out to be wait a minute. Oh, wait. We have to write the answers in. 7 and 0. Okay, that's better. I was like, what is going on here? So we have 1 times 0. So I'm supposed to write 7 and 0 in for y, 1 and 2 for x, 7 and 0 for y. 1 times 0 is 0. Minus 7 times 2 gets us minus 14. So now we have x is dx over d, which is 7 over 7, which is equal to 1. Y is dy over d, so dy minus 14 divided by 7, which is equal to minus 2. So our solution set is 1 minus 2. And so that's how you use determinants to solve a system of equations. So we have d, which is based just on the coefficients, the multiples in front of the variables, the coefficients here. We have dx, where we take the solution set and replace x with it, 7 and 0 instead of 1 and 2. We have dy, where we take the y's and we place 7 and 0 in the y's. We have 1 and 2, 7 and 0, and that gives us 7, 7 and minus 14, and then we can solve for x and y by doing dx over d and dy over d. And there are several good examples in the book of this. Look back in the section in 3.3, and you can see the examples there for you. All right, that's how you do those problems. I will see you on Monday, where we'll go over these, make sure we've got them. But you need to solve your 2 equations and post them online, your 2 problems, and post them online. All right, I will see you on Monday.